Why the greenhouse effect does not violate the second law of thermodynamics. I often hear this argument, and it's not true, it's not correct. So I was looking for something to illustrate this, and I found this little illustration, which is from PhET. This is their website. I'm going to post a link in the description. They have wonderful simulations about lots of things. And I found this little simulation. So let's run it. I'm going to start by putting the water up here, and then I shall heat it. And that was kind of boring, so I will click this. Now I can see the energy inside here. And when I heat, you see energy coming from the fire into the water. You can also try cooling it. Now you see energy going the other way, and some still going up. But let's heat it. Now you see it's starting to steam, and energy is escaping at a high rate. Now the water is actually in steady state, which means that the energy going into the water and energy going out from the water flows at the same rate. That's steady state, so nothing changes. All the flows are constant, all the conditions are constant. Now I will reset. Then I'll put the water back, and now I'll also put the olive oil. And I'll link the heaters so that I can heat both of them at the same time. And let's see. Both are heating up now. And their energy is starting to escape the oil. And now the water, and now you see the water is faster, because there's always an element of randomization in these simulations. So it's just a probability of an energy escaping each of these beakers. But eventually they will both reach a steady state. Okay, now what's the point here then? I'll get to that. Put in the water back, energy symbols, link heaters, and now we'll put a thermometer in each of them and just do the same thing again. What do you think is going to happen? Same thing, energy going in, no energy yet escaping. Let's see who escapes first this time. Oh, oil again. What do you know? Now water. And water again is now faster than the oil. But what about the temperature? About now, it seems they have both reached steady states. Inflow and outflow are the same. But the temperature is much higher in the oil than in the water. You can try this in reality if you want. Because this is how it is. Just because the inflow or energy is the same doesn't mean that the temperature has to be the same. So often when people give this argument that the greenhouse effect violates the second law of thermodynamics, they also claim that the temperature of Earth is decided by the inflow of energy from the sun, in this case. But as you can see here, and it's also true in reality, the flows of energy do not determine the temperature. The temperature is decided by a combination of the flows of energy and the properties within the water and the oil or whatever object we are dealing with. So this could illustrate Earth without a greenhouse effect, for example, and this could be Earth with a greenhouse effect, where it's just slightly more reluctant to give off energy. So it gives off energy slower at the same temperature. Or, in other words, in order to give off energy at the same rate, it has to reach a higher temperature. And so the argument that the greenhouse effect violates the second law of thermodynamics builds on an assumption that the greenhouse effect requires the atmosphere of the Earth to be warming the Earth, which they say it cannot do because the atmosphere is cooler than the Earth. And the second law of thermodynamics basically states that a cooler body cannot passively be warming a warmer body. But as you can see, it doesn't at all require that. All that the greenhouse effect requires is for the atmosphere to make it slightly harder for the Earth to get rid of energy. Because when that is so, then at a steady flow, at a steady state, where the inflow and the outflow of energy are the same, the system for which it is harder to get rid of energy will be warmer. And that, of course, doesn't violate any natural laws at all. The greenhouse effect could do that. And that's all I had to say. Bye for now.